Warm greetings. Welcome to the course on Computer Networks and Protocols. This course is a prerequisite to CCNA, that is an international certification course. If you want to demystify all the networking technologies and jargons used in the networking field, then this course would be an essential thing to fulfill your expectations. This course is divided into 5 units, in which the first unit will be an introduction to networks. In the first unit, the first topic would be topologies and different types of network. The general objective of today's class would be, at the end of this session, the students will be able to understand different types of network and different topologies of network. There are 3 specific objectives. The first specific objective of today's class would be illustrate different types of networking topologies. The second specific objective would be interpret different types of network. The third specific objective would be compare one type of network from another type of network. First, let's see what is networking. A quote says that a networking is found everywhere. Imagine you have completed your schooling and entering into the college newly. So, you doesn't know anyone in this college. You create a network. How you create a network? You speak with your friends, you form a friends group. So, you create a network there. You interact with professors, you form a network. So, a network is formed by students, a network is formed by professors. In your entire study, you could have come across with many workshops, seminars, etc., in which various industry persons comes and teaches you. You form a contact with those industry persons and form a network. Okay, so this is all about networks. To be precise, network is a fancy word of building a relationship, right? Now, what is a computer network? You replace the student with a computer. So, a group of computers together form a network. When 2 or more computers join together or connected together in order to communicate with each other, then this is called as a computer network. So, when 2 computers join together or when 2 computers are interconnected with each other, there exists a problem that the information transmitted should be read by another computer. For instance, we have seen an example, okay? When your friends doesn't know your own language, that is, imagine that you alone know Tamil and English, but your friends know only Hindi, okay? How can you communicate with them effectively? It is not possible, right? So, the computers should obey a set of rules and regulations in order to transmit information with each other. This is called as a protocol. Okay, so a protocol is a set of rules and regulations that is framed for a computer in order to transmit the information from one point to another point. That is what we told the subject name as Computer Networks and Protocols. In this entire course, you will be seeing different networking concepts and different protocols which enables the system to transmit information to another system. Secondly, the network supports the way we learn. How this is possible? Imagine I am taking this video lecture in Banariaman Institute of Technology. but you students can view this video from any part of the country. So the network supports the way we learn. Next, the network supports the way we communicate. Imagine a scenario in which the landline phones has been used. Only there will be a voice communication, right? Now, you can see a smart mobile phone with many different applications. Let's take one application, that is a WhatsApp. You can make a voice call, you can make a video call, you can transmit audio messages, you can transmit text messages, you can do whatever you want, right? Or you can transmit any information that you need. So the network support the way we communicate. The network support the way we play. There are many games today, that is even cricket, a group of people can join together and play a cricket, right? So the network support the way we play. We can find many benefits when two or more computers join together. That is, they can share the resources among the computers. When a network doesn't exist, how the resources can be shared? The resources can be shared using a pen drive or a floppy disk or a CD, etc. So the benefit here for creating a network is the resources has been minimized. The information has been transmitted. The networking allows us to store the information in a centralized location. That is, imagine I've created this video and uploaded in YouTube. So it has been stored in the centralized part. Any persons can view this video from anywhere. They can access this particular information. And this can also be secured. The networking can also implement many security policies. For instance, the video is uploaded in YouTube and I can create some privacy. The video should not be viewed by everyone, or the video should not be downloaded, etc. I can give some security features to that. And finally, the network can track and monitor the resources. Next, let's discuss the purpose of computer networking. The major purpose of computer networking is data sharing. Before the evolution of computer networks, we use CDs, pen drive, floppy disk and few other data storage devices in order to transmit information from one computer to another computer. But due to the existence of computer network, if we have to transmit the information from one computer to another computer network, we use an Ethernet cable to connect two computers, or we use a networking concept in order to connect two computers and share the information from one computer to another computer. By this way, the resources has been properly utilized. That is, the unwanted resources has been eliminated and proper utilization of resources has been done by using networking concepts. The second purpose of computer network is resource sharing. So from this example, you can see that I need to connect printer to 4 different systems. Okay, imagine a scenario that I have to connect printer to 4 different systems. So before the evolution of computer networks, we will be connecting individually. For individual system, an individual printer should be connected. But by the existence of computer network, if you have to take a print job of any systems, of any 4 systems, you can connect all these 4 systems to a switch or hub, and from any one of the system you can connect a printer, which means that all the 4 systems are connected to a single network, and from this network the printer has been shared, so that you can take a print job from any of the 4 systems. By this way, the resources has been shared. So, 4 printer concept has been eliminated, the resources has been eliminated and only one printer has been used in the network. The third purpose of computer networking is application sharing. As the name suggests that the application, a single application can be shared with n number of peoples. That is, for example, let us take a YouTube. The YouTube can be shared to n number of peoples and anyone from any part of the world can access this particular application. This application sharing is mostly used in the company environment, and in the companies usually a project is assigned to several users or a team which has a several member. Generally, if you take in a company, a project will be assigned to a group of 10 members with the project team lead, and the project team lead has a control over all the softwares which is associated in the company, and even the company persons can take the access over that particular software and they can access anywhere at any parts. And this networking allows the concerned users or members to work on the assigned project simultaneously. And besides this, it is also used for troubleshooting. For instance, let us take, I have an broadband connection in my home and I have some errors occurred in the modem, and due to the lockdown scenario, the service engineer could unable to come to my home and attend the service. So, the troubleshooting can be done in online. That is, I have installed a TeamViewer software and I have shared my ID to that particular service engineer. So, the service engineer takes the control over my system and troubleshooted the modem and found the fault and rectified it. So, this using this network or using this application sharing concept, the troubleshooting and accessing a network device or a computer can be done remotely. And next, let us discuss the components of a network. Till now, we have seen the purpose of a computer network. We have discussed what are the features that the computer network has. Now, let us say how to create a computer network, or if you have to create a computer network environment, you need certain devices in order to create that particular network. So, the components required for creating a networks are, first is network devices, network navigation devices, network adapters, network media and network protocol. First, let us see about the network devices, or I can term this as network end devices. So, in order to establish a computer network or in order to establish a network, generally you need an end device. So, end device means a computer, or here the end device means a printer. A printer job should be done and the printer should be connected to a network. So, the end device would be a printer here, or the end device can be a scanner, or the end device can be a cash drawer, or the end device can be a Bluetooth scanner, so which is used in libraries. So, this also will be connected to a network. So, the end device can be a tablet, the end device can be a mobile phone or etc. So, network devices or network end devices means a computer or a mobile or any end devices which is connected to a network. Next, let us see the network navigation devices. Network navigation devices is associated with this network end device in order to connect to the network. For example, if you have to connect hundreds of devices or hundreds of end devices to a network, it is not possible directly because you require many number of ports. So, a network navigation devices are used in between the network end devices and the network. There are 6 different types of network navigation devices. The first is hub, the second is a gateway, a third is a router, fourth is a repeater, fifth is a bridge and a switch. These are few network navigation devices which is connected with the network end device. Let's see the network navigation devices in detail. First, let's take a hub. A hub is a physical layer networking device which is used to connect multiple devices in a network. Okay, you can see an animation in the screen. Okay, so this blue color part indicates a hub. Here in this example, there are 3 hubs connected with each other, and in each of the hub 3 systems are connected. These 3 systems are nothing but called as the end devices, right? So 3 computers are connected to each of the hub. Okay, now assume that I have to transmit an information from this green color system, okay, this green color system or this blue color system to this green color system. Okay, what happens? The information from this system is transmitted to this hub. Okay, what a hub does is, the hub is a non-intelligent device, which means that the hub receives the information and forwards the information to all the ports that is connected. Okay, so what does this hub does? The hub receives the information from this system and forwards this information to all the ports which is connected in this hub, so that this information will be received to all the system in this hub as well as in this hub. Okay, because these 2 hubs are interconnected with each other. You can see here these 2 hubs are interconnected with each other. So the information from this system is also transmitted to this hub. Okay, and what does this hub does? It receives the information from this port and forwards the information to all the other ports, so that all the system connected to the hub receives the information and all the hubs connected with the hub also receives the information. And finally, the third hub, if you consider, now this information is propagated to this hub. What does this hub does? It forwards all the packet information to all the ports. Okay, finally it reaches to all these 3 systems also. So the information has been successfully transmitted from this system to this system. Okay, now what could you see here? The resources has been wasted here, right? Because as the hub is a non-intelligent device, it has no intelligence in it, the hub simply collects the information and simply forwards it to all the devices which is connected in that particular hub itself. Okay, that is, when a data frame arrives at a port, it is broadcast to every other port without considering whether it is destined for particular destination or not. Next, let's see a gateway. A gateway is a device which is connected between 2 different networks. Here you can see there are 2 different networks are present, that is, segment 1 represents the first network and segment 2 represents the second network. So whenever the information has to be transmitted from one network to another network, you can use a gateway, or the information from one network to the same network can also be done through this gateway. But here the gateway is an intelligent device. So what do you mean by an intelligent device? So when a data is transmitted from PC1 to PC2, the packet contains a header file. In that header file, there will be an address of the destination. So when PC1 has to transmit an information to PC2, PC1 transmits the information directly to the gateway, and this gateway identifies the MAC address or the destination address and forwards the packet to the destination address. This is a function of a gateway. There is another function of a gateway, that is, a gateway can convert one type of protocol to another type of protocol. Okay. Previously, we have told that when two systems are interconnected with each other, it should operate under a common protocol or a same protocol. For that, we have told an example. When two persons are communicating with each other, if they doesn't know the language, then it is very difficult to understand, or the communication there is not an effective communication. Okay. So the network should operate on a common protocol, or it should have a same protocol for communication. But here let's assume an example that a PC is connected with a TCP IP protocol and a PLC is connected with a control net protocol. And if I have to transmit the information from this personal computer to this programmable logic controller, what happens is we can use a gateway in between. Okay, you can see the animation here. The PC transmits the information, that is with a TCP IP protocol, and this gateway converts the information or converts this TCP IP protocol to a suitable control net protocol and then propagates here. Okay, so this is the function of a gateway in networks. And third is router. This router routes the information to the destination. When you consider hundreds of devices associated with each other, imagine that you have multiple number of networks. Okay, so consider this example. This example contains a red network, okay, an yellow network, a blue network and a white network. Okay, assume that it contains 4 different types of networks. Okay, now an information has to be transmitted from one network to another network. Okay, for that we can use a concept called as a router. What does this router does is it receives the information from one system and it routes the information to the destination system via a simple routing algorithm. Okay, in the forthcoming classes we can see many different types of routing algorithms. And the next device is repeater. Okay. The repeater is same as that of a hub. Okay, what we told in hub, the hub is a non-intelligent device. Repeater, we are going to say the same thing. Repeater is also a non-intelligent device. So why it is used in the network? It does a job, that is, whenever the data has to be transmitted over a long distance, okay, through a wired medium, whenever the data has to be transmitted to a long distance, the data at some point may get weakened. So to boost up the data or to amplify the data, we can use a repeater. So the operation of a repeater is it simply receives the information, it boosts the information or amplifies the information and it propagates to all the other systems which is contained in that particular repeater. Here you can see in this animation that whenever the data has to be transmitted, the green color transmitted data, okay. So, here this is a repeater, the repeater receives the information, it modifies the information, that is it amplifies the information and retransmit to all the other ports or all the other systems which is connected to this repeater. Okay. Here you can see an example which is a wireless. Here the information is transmitted in a wireless medium. So, in wireless medium, if the information has to be transmitted to a longer distance, the signal gets weakened. Okay. In order to boost up the signal, the repeaters can be used. And the next device is bridge. When two different networks are to be interconnected with each other, then we can use a bridge here. When the information from PC1 has to be transmitted to PC2, the information will be transmitted to the bridge and this information contains the destination address, so that the bridge can retransmit the packet to the destination. We can see another example, that is we contain two networks here. When the information has to be transmitted from PC1 to PC8, what happens here? The PC1 transmit the information to this bridge. Okay, this bridge finds the PC8 by using the MAC address or by using the destination address and transmits the packet to the PC8. Okay. So, imagine when the network is very larger, when we have 10 different type of network or when we have 20 different type of network, this bridge can be very much essentially used or very much effectively used. And next is a switch. A switch is also similar to that of hub, but the major difference between a hub and a switch is, hub is a non-intelligent device, but the switch is an intelligent device. Here you can see each and every systems can be connected to a switch. For an example, we have assumed that there are 4 PCs connected to a switch, and when PC1 has to transmit information to PC4, see, the PC1 transmits the information with the destination address, okay, with the PC4's destination address. So, as soon as the switch receives the packet information, it decodes the header file. Okay. So, in that header file it contains the destination address, so that the information can be reached to this destination directly. But instead, if you look into the hub, what does a hub does? It retransmits the information to all the other devices. That is the major difference between switch and hub. Okay. Next, let us see about network adapters. Whenever a computer has to be connected to a network, you need some network adapters. That is, an Ethernet port is used to connect a system to a computer or a PC to a network. You can see here, this is an Ethernet port. By using this Ethernet cable, you can connect a system with a router or a bridge or a hub to a network. But due to the advancement, many ports are readily available now. That is, the Ethernet port can be converted to any ports, that is a HDMI port or a type C port or a type B port, and connected to a systems. So, not only a Ethernet port can be connected to a network, an Ethernet port can be connected to a network, or a USB can be connected to a network, or by using a HDMI cable you can connect to a network. There are another network adapters, that is, Whenever we require a huge amount of data transmission in a network, we use optical cables. Okay, for example, in mobile communication, if you take two base stations and between the base station you can see a huge number of datas are to be transmitted. So an optical cable will be utilized in order to transmit the data between two base stations, and we can use an optical adapters here in order to connect it to a network. So the network adapters can employ an Ethernet port using an Ethernet cables or an optical port using some optical fiber cables. Next is the network transmission media. First, the transmission can be done using a wired medium or a wireless medium. If you take a wired medium, two types of transmission media are present. One is using copper cable, the data can be transmitted. The second is using optical cables, the data can be transmitted. Whenever a system is connected using this copper cable or a twisted pair cable, the data can be converted to an electromagnetic signal and transmitted via a copper cable to reach the destination. The second option is the data can be converted to a light signal and transmitted via an optical cable to reach to the destination. These are the two different modes of transmission through an wire. Next is a wireless transmission. Through a wireless medium, the network can be created and the data can be converted to an electromagnetic signal, and by using antennas we can propagate the signal to a free space and transmit the data, as well as we can receive the data by using an antenna and convert the signal into an electrical signal, and we can use the data. So next is the network protocols. As I told you already, protocols means a set of rules and regulations followed in order to transmit the information from one system to another system. From this diagram we can see that there are many different protocols which is available. So for basic connectivity protocols you can use TCP, UDP, IP, ICMP, ARP and NDP as a protocols. And for encryption protocol, that is in order to transmit the data with some encryption algorithms, we can use SSH protocols, SCP protocols, SSL protocols, TLS protocol and IPsec protocols. And for application level protocol, whenever you have to browse anything from the websites, you can use HTTP protocol, HTTPS, which is of secured connection, a file transfer protocol, FTP, SFTP, FTPS and TFTP. These are few application protocols. And for email protocols, you may use SMTP, POP3, IMAP4. So these are different network protocols which is utilized. Protocols is nothing but a set of rules and regulation which is inculcated for transmission of data from one point to another point. Let's not go into detail about this network protocol, because in the forthcoming sessions we will be studying in detail about this network protocols. Next, let's see about the network topology. First, let's see about a point-to-point topology. Next, a bus topology. Next, a ring topology, star topology, mesh topology, tree topology and hybrid topology. So, why a topology is used in a network? That is, whenever you have to connect a computer to a network, or whenever you have to connect many different computers to a network, depending upon the variety of application, there should be some connection procedure. That connection procedure we term it as a network topology. First, let's discuss about point-to-point topology. In point-to-point topology, you can see from this animation, each and every system should be connected to another system. For example, if you take two systems, system X should be connected to system Y. If you take three systems X, Y and Z, system X should be connected to Y as well as system X should be connected to Z. That is how you can see in this diagram. Let us take this system alone. This system will be connected to all the four systems, okay, all the four systems with a weightage factor. See, with the weightage factor, the system will be connected to all the different four systems with some weightage factors. That is what called as point to point topology. Next is a bus topology. Bus topology, as this word indicates, there will be a common bus line, and from this bus line all the systems will be interconnected. Imagine a bus, a public transportation bus or a private bus. Imagine that in a bus many number of seats will be connected. A single bus, many number of seats will be connected. Okay, so this is a bus, and assume all the systems to be, all the personal computers to be seats. So each and every seats are connected to the particular bus. Okay, as we told in the hub, this particular bus also doesn't contain any intelligence. Okay, this bus also doesn't contain any intelligence. That is, when a data from PC1 has to be transmitted to PC8, what happens is, first the data from PC1 will be transmitted to this system PC2. If not, then it transmit to PC3 and 4. If not, it transmit to PC 4 and 5, 5 and 6. If not, it will be transmitted to 7 and 8. So finally, this accepts the information and all the other discards the information. So this is about bus topology. And next is ring topology. In a ring topology, each and every individual system will be connected with two other systems. When you have to form a network with 6 different systems or 100 different systems, you should form a ring-like structure. So what do you mean by a ring-like structure? If a system is connected in a network, it should be connected with two different systems. Okay, if I consider this second system, it should be connected to 1 and 3. If you take the third system, it should be connected to 2 and 4. If you take this fourth system, it should be connected to 5 and 3. If you take this fifth system, it should be connected to 4 and 6 and so on. If you take 100 systems, it can be connected, but the main condition is it should be connected to two nearby systems in order to form a ring type structure. So if the information from 1 has to be transmitted to 4, what happens? The information from 1 passes to information 2, the information from 2 passes to information 3, and the information from 3 passes to 4, and finally the data packets from 1 reaches the receiver, that is 4. Okay, so this is the operating principle of a ring topology. Next, let us see about a star topology. In star topology, a switch or hub will be connected. Okay, there will be a centralized point, and in that centralized point a switch will be connected or a hub will be connected, and from this switch many number of systems, if you take 10 systems, 10 systems can be connected by using this switch or hub. Now assuming a star topology with a hub, what happens when a system 1 or when a server 1 has to transmit an information to this system? The server 1 transmits the information to this hub broadcasts the information to all the other systems. Okay, assuming a star topology which is connected with the switch, what happens? The server has to transmit the information to this system. The server transmits an information with the destination address of this particular system, so that when an information is transmitted, the switch directly transmits the information to this destination. This is how a star topology works. Next is a mesh topology. In a mesh topology, so it is somewhat similar to that of your point-to-point topology, but here the mesh topology can be divided into two parts, that is partially mesh or full mesh. Okay, first let us see a full mesh topology. Okay, in a full mesh topology, each and every individual systems should be interconnected with the all the other system that is present in the network. Okay, assume this system. Okay, this system is connected with the second system, this system is connected with the third system, this system is connected with the fourth, this system is connected with the fifth system, and this system is connected with sixth system. So each and every individual system should be connected to other individual system respectively. For example, if you want to have a network of 50 numbers, okay, if you have to form a network with 50 different computers, then imagine that you should have 50 Ethernet ports in your system in order to maintain a full mesh topology. It is a difficult task, but these are used in many applications. For example, if you see at the beginning of evolution of network, all the military purpose, they use these kinds of mesh topology in order to connect a network. Or even you can see, so you may do many projects, even in some automation projects, if you use Zigbee technology, then this supports the mesh topology. Okay, then what do you mean by a partial mesh topology? Depending upon the hierarchy of the system or depending upon the weightage given to the system, some number of loops can be eliminated. That is, let us consider this as an example, this first system as an example. The first system can be connected to a second system and third system because the weightage given to this is very low. The first system is not essential to connect with 4, 5 and 6 because the weightage will be more here. Okay, that is what called as the partial mesh topology. And next is a tree topology. Okay, you can see the structure of a tree topology from this diagram. The tree topology is a combination of two topologies. From this diagram you can guess. Can anyone guess what types of topologies are associated here? Yeah, hopefully some can guess here. That is, a backbone cable is connected here. What do you mean by a backbone cable? Where, in which topology we have adapted this backbone cable, or in which topology we have connected a common line here? In bus topology, right? This backbone cable is nothing but means as a bus topology, and from this bus topology you are connected with a different number of systems, and this different number of systems is connected via a hub or a switch. Okay, whenever you connect a system with a hub or a switch, then what topology does it means? It means a star topology. Okay, so this tree topology is a combination of a bus topology as well as a star topology. Okay, the next is a hybrid topology. In a hybrid topology, you can combine many number of topologies in order to form a single network. Okay, here in an example we can say that a hub is connected with a different number of systems. So what does this topology means? This topology is called as a star topology. This star topology is connected with a common backbone. So whenever a common backbone is used to connect many systems, what does this topology means? This topology means a bus topology. And this hub topology or this hub is connected with another system in which these two systems, this system is connected with another two systems. That is, for example, if you connect, if you say this as a system A, the system A is connected with system B and system C. So what does this topology means? This topology means a ring topology. So in this topology, there are three different types of topologies which are merged together. So whenever you combine two or three topologies together and form a network, then this type of topology is called as hybrid topology.